Hey, good morning everybody. It's morning for me. So today I'm going to go ahead and talk about my car. So basically it was like I watched an asteroid strike my car. Naturally an asteroid didn't really strike my car, but what's really cool about this is the fracture it left behind as it struck the windshield of my car, this object. Very large object. I think it must have been at least the size of the fracture in its oval shape. The fracture of its oval shape is about this large, if you can see that. Maybe if I don't have my face behind it. And anyhow, it was very unique in its design, if you want to call it that. So basically what we're looking at here is that's my car, and I parked that way, and I don't like the front of the car going to the right, so I flipped it and made it go to the left. Here's my line. The red line is just basically my line in the object that shows you, if we go to size, go floor mat, and we're going to go size over here. Size is going to give me 0 degrees, right? And then I'm going to rotate that object. I colored it yellow now to maybe possibly see it a little bit better along the windshield. I rotated it clockwise until I reached 61 degrees. Then I took a picture of this particular frame for NASA and 2 scientists that I sent the PPT to. Well, no one ever talks to me. So who knows if they look at it or not. But if they're interested, it's really good details. I was actually amazed at just how much it resembled an impact crater of the compared to the many impact craters that I've identified on our planet, its surface, and trying to basically convince NASA that some of our scientific criteria for identifying craters, say for instance on the moon, does not necessarily always apply on Earth. And mostly because the Earth has an atmosphere, the moon barely has anything, if any atmosphere. I don't believe it has an atmosphere. And so there's deflection when you have an atmosphere. Deflection has a great impact on the impactor as it enters that volatile region. So now I'm going to come down here. We know that it basically, my windshield is set at 61 degrees. Well, from your point, like that, right? So it's at 61 degrees. And basically we could say that that is a specific region on the face of any planet. We'll call it Earth, but in this case it's a planet VW. And it's going to tell us approximately where that object would have struck the Earth if my car was a planet. Alright, now, this is the stuff I really love right here, right? So here we have my Google planet Earth, and the red line, as you can see here, is the ecliptic in relation to this particular view. And this white arrow here takes us down to the North Pole. When I did this particular view of the planet, I had to bring the North Pole forward toward the viewer just enough so that the North Pole could be seen, right? Then, from the center of the planetary view, I draw a line in the same way that I did the Volkswagen line to determine the axial cant of the windshield. I did the same thing here, right? I probably made that sound really dumb the way I worded it. Well, these 2 yellow lines now mark the galactic plane region. Not that the galaxy is as skinny as, you know, the top yellow line and the bottom yellow line. It just basically, the truth of the matter is I couldn't get the circle tool to go any farther down than where you see it right there around the Earth's surface, because that's pretty much where the view stops, and it doesn't go beyond the view to the equator. But yet it leaves a nice little band right there too, right? And this basically is Earth's galactic flight posture, or GFP, orienting the North Pole at approximately 25 degrees above the galactic plane. Now, I'm going to go back here. Did I put anything up here? No notes, no notes, no notes. Okay, no notes here. This is my first screen with notes. The tangent of Earth's surface relative to the vertical angle, VA, of my planet VW, laugh out loud, indicates this theoretical impactor would have struck the Earth someplace along the... I should have put a ... Okay, so basically the reason was at this particular screen set, you'll notice I didn't have any of the longitude or latitude lines on the planet given, so I couldn't finish the sentence. And apparently forgot to go back and finish it before I sent it off to NASA. And so here's my next screen. We're starting to take into a different consideration. I took my galactic markers, basically, and changed them from the color yellow to the color of neon green, but I did that so that they would not be so, conflicting with my the primary vortices outlines. I also wanted the viewers, the 3 target viewers that I had, to see how this would, work in line with the vertical or the primary vortices. And so in this particular view, we'll go to the next one. That's just my picture that I made that I copied. So now we're going to go to the next one. Oh, there it is. That's the one. This is the one where I actually start to tell you what everything is. So we got my VW windshield vertical angle going across here, and it's that angle at 61 degrees that touches the top of our planet. Okay? And so if our planet was actually planet VW driving down the highway in the state of Washington, that's where the windshield would have been smacked by the unknown object, whatever it was. Yellow, gold, not gold, but more like yellow brassy looking. Like it could have been a really dirty manifold flying through the air, a small one, right? So now we have the Arctic vortex, and the Arctic vortex has its rotation counter to the planetary rotation. And everybody knows what the planetary rotation is, which is prograde. The Arctic vortex is retrograde. And then you have the North Band of Basin vortex that's rotating clockwise. You have the Lake Victoria vortex that's rotating clockwise. Then you have the Sapaliwini vortex from the Sapaliwini forest in the Amazon, rotating counterclockwise. Those are the only primary vortices that are generally visible in this particular view. And then, of course, I have my red ecliptic coming across here. What is the ecliptic? The ecliptic is basically the Earth's orientation in relation to the solar system plane. All right? And this is Earth's orientation in relation to the galactic plane. Next screen, right down here. Now I'm going to go ahead and read this to you. All right. The yellow positive symbol illustrated above indicates the approximate location of this theoretical impactor's POI. X marks the spot. Only trouble is you can't take the plus symbol and turn it into an X. But I mean, if you were looking at it from a different perspective, it might look more like an X, right? Like something you might see when you see an X marks the spot in Minecraft. Well, anyway, that's it. So where is it? It's at about, well, you have 50 north, and then you have 30 north down here, makes this latitude 40 north, makes this latitude 60 north, and this is really close to 60, but it's not 60. So it's approximately 58 degrees north latitude. So anywhere along our planet, this object could have struck at this point as the planet would have been rotating. Okay? Now, the only difference here This is a new perspective I have. It's like, I was going to say if my Volkswagen was rotating when the object struck, it would have been rotating in a prograde direction, meaning that the left front quarter panel would have been rotating counterclockwise, right? And which would be the case if you're looking at the North Pole. The planet rotates counterclockwise, but I have the wrong impression of how my car would have been rotating. It would not have been the front quarter panel rotating counterclockwise. It would have been my VW rotating like it was rolling down a hill. Very different. Very, very different. And then it would be rotating toward the right, not the left. I didn't see that before. Well, anyway, that means that the impact would have been less tragic and maybe not quite so damaging as it was, because my car wasn't rolling away from the object as it struck. All right, so the yellow positive symbol illustrated, I already read that to you, didn't I? Okay. The impactor would most likely have struck the Earth someplace along the 58th latitude. This perspective of the Earth's GFP positions the observer between the Earth and the Earth's parent black hole, BH number 1. Okay, so what I don't have here is it's called, what kind of galaxy do we have here? We have a barred spiral galaxy. So in a barred spiral galaxy, you can only have, these are my theories, you can only have 3 black holes, all right? And the reason that is because if you go into 4 black holes or more, you end up with a hub. All right. It's just the way things go, right? You end up with that hub. So the only way you're going to get linear is if you have only 3. How's that going to work? Well, they can't all 3 be the same size. So what you have to do now is you have, I used to think it was going to be 2 siblings, one on the left, one on the right, and one big fat bugger in the middle called Mom and Dad. But I changed my mind. As the course of time progressed, I determined that that wasn't compatible with logic in the operation of our galaxy. So I have determined since that Mom is like either left and right, and Dad is either right or left, and because it doesn't really matter. I mean, they're all basically, the one on the left and the one on the right are probably somewhat equal in size. They would have to be somewhat equal in size. Please excuse Doodle. In order for the galaxy to remain stable. And then the black hole in the center would have to be the idler black hole. Basically just there because it's more like a pearl in a clam's mouth that's just stuck. And it just builds, and it's not really a pre-existing product of the linear arrangement. It is a byproduct of a binary arrangement. Okay, now that we figured all that stuff out. Now, the observer is looking out and beyond the Milky Way galaxy, the MOG as I like to call it. The theoretical asteroid would have originated somewhere within the galactic interior. And when we talk about the galactic interior, if this is where our black hole is, and over here is where planet Earth is, or planet VW, galactic interior is going that way. Galactic anterior is going this way. All right, then we're going to go down. You notice I have to yell at my computer. It's a good thing the wife is visiting the daughter, because I'm like having to yell to talk over Doodle back here, who thinks she should own the floor. She's one of those sorts that has to be the center of attention always. Isn't that right, Doodle? See, now she shuts up. She's like, "What? You talking to me?" Oh, now that was her F you and me. Okay, now Boomer and Monkey are sitting down. They're just chilling. They're laying down, being good puppy dogs. Okay, I will analyze and conduct a continued evaluation of planet VW's impactor and determine its size relative to the imaginary planet's surface. Then I will compare planet VW's impact crater to how it would appear on the Earth. That was the fascinating part. That's the part I just love because it looks exactly like, no, I take it back. It looks really close. It has the same components, just not exactly in the same arrangement of impactors I've identified on the planet. All right, now, I was going to give you a little sneak preview, but I don't want to let that loose yet. I'm going to tell you about that secret later. Okay. The Hawaiian impactor struck the Earth's surface in much the same manner. Yes, the Hawaiian Islands formed around an asteroid impact crater. And I have a video on that. Anybody can go view it. There's going to be a lot of haters out there and a lot of non-believers, but you can't refute the evidence. I just wish I had the money to go down there and get core samples of all these, points of impact and points of penetration where these things from space struck the Earth, and find out when they struck. That would be cool. All right. Okay, the galactic plane in relation to the Earth's North Pole orientation changes. This perspective hides the relatively consistent ecliptic. Notice the galaxy in the background relative to the ecliptic. And as you can see here, I arranged my view of Google Earth so that the ecliptic that goes all the way around the planet is completely hidden. It's basically, you might say, the planet's equator in a sense in this particular view. Not that it is, it's just set that way so it's perfectly at the half, okay? And as you're looking at it, even in Google, we can see that we have the galaxy just behind back here. Now, what you also can tell is that the North Pole is oriented closer toward the galactic core, galactic center, right? And it's, so it basically is telling us that the ecliptic is further forward and closer to the North Pole orientation toward the galactic interior. That means that our solar system, believe it or not, is actually like if this little guy right here is our black hole, we're going around it, and the solar system from your point of view would be going this way. It's angled, my hand would be angled like this, right? And wait, like that. Wait, like that. Wow, that's hard to figure out. All right, here we go. I got it right. Now my hand really can't hold this shape. This is kind of hard, and it's going this way. Makes that sound too. I know I was there. Okay. There it is. All right, now we're going to go to my next PowerPoint. This is the one where I actually start to analyze the fracture. Now, so I live down in Chehalis in Washington State. And it just so happened one day I was driving down the freeway, I-5 right here, and you can't see it here, but immediately to my left there are two bridges. And one day there was really heavy billowing smoke coming up between the two bridges. And so I went down to the very next off-ramp, which was Chehalis at this point, and turned around and came back, and then had to go to Centralia, turn around and go back. And then this is kind of like, there's like this side road right here paralleling the freeway that goes between Centralia and Chehalis. And I got to the bridges, and I parked on that side to the right of the on-ramp traffic. I parked to the side right here, of the left side of this Jersey barrier. And it wasn't until after I had to climb over, I'm freaking old, and I'm sitting here trying to straddle this freaking Jersey barrier like I'm still in the Army. And I climb over, and I clumsily walked over this way. This is a bridge, and I went down back behind over here and down a hill, and my knees were just like this. I could barely even walk down the hill of rocks, but I went down far enough. I just had to make sure that as I was going down there, that the smoke from the fire that I had seen was not spontaneous and at risk of spreading. And I confirmed that it was a person there that was, had a little campfire going, making dinner. Okay, so once I figured that out, I came back up here. But the good thing is, after this great big bliggity-blagget smacked my car, it was the only place I could think of, and I didn't even think of it immediately, but this service road I knew was here, and then I was like, I could use the service road to basically back my car into there and sort of try to orient my car in relation to where it may have been approximately at the time I witnessed the object flying through the air before it smacked my windshield. Now, this is only an approximation on my arc of flight because it was a split second, just like that. I had no time to react, nothing I could do. It was just like, oh, here it comes. It's kind of one of those things where you're just like, okay, I'm going to die. And bam, it hits, and you're just like, huh? I'm still alive, holy shit. And you keep driving. All right. And luckily, I'm used to getting shot at and having things explode around my head, so I just kept driving through it. If that would have hit some folks, it might have scared them so bad it could have caused an accident, you might think. So, thank God it struck me. For two things. Thank God it struck me because I'm just like, okay, I'm still alive, keep driving. Secondly, thank God it struck me because it gave me the perfect opportunity to analyze an impact crater on my own car. Alright. So, it comes across here over the median. I have no idea. It wasn't one of those situations where you're driving down the freeway and you see an object like a very large rock falling out of the back of a dump truck going doink, 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 doink across the freeway like I have seen following dump trucks in the past. Which, by the way, if you don't know this already, when you see a dump truck on the freeway, they're not liable for anything, apparently, that might strike your car from within a distance of 200 feet, okay? So if you're closer than 200 feet behind a dump truck and something comes out and clobbers your car, it's on you. 200 feet, that's a lot of distance there, folks. Okay? Now, well, at least that's the way it is in Washington, I guess. So anyway, you're going like this, comes down, hits here, and then I swear when I was sitting in the car, it looked like it went doink straight up. But that is not consistent with the fracture. So it had to have gone off like this, and it's not like I really could tell at that point. It's like these things, you're going down the freeway, you see it at about this point here, and then it just kind of disappears. And then the next thing you know is, bam, it strikes your windshield, scares the crap out of you. You jiggle the steering wheel a little bit, and then you're just like, okay, I'm okay. And you keep going, right? So, now we're going to come over here to my next picture. And this is where I take my vertical angle. So, I have basically drawn a line, the white line, bisects the fracture from the basically in the center from longest point to longest point to give us what would really be the our back. It also tells us the back azimuth to where it came from, and then from that we also get the plane of the glass as it struck, and then we measure the angle between the plane of the glass where it struck and the arc of the object as it struck the windshield upon approach. It's the same thing you do when you're determining where an object came from outer space before it struck the planet. The only trick to being able to do that logically is you also have to know where was the planet in the solar system when it occurred? Where was the solar system in the galaxy when it occurred? And where was the galaxy in the universe when it occurred? And most importantly, when did it occur? Right? So, without knowing those things, you will almost, I promise, not be able to determine exactly where the object came from. Was it extragalactic? Was it from the galactic interior? Was it from a nearby exploding star, you know, in a nova? What was it? Where did it come from? Where did it really strike us, you know, from what angle and stuff? Was it from under the galaxy? Was it from above the galaxy? These are things you never know until you get those, you figure out where the planet was and how it was oriented at the time of the impact. So let me go back over. Do I have any notes on that one? I don't think I had any notes up there. That's the first one. Then I had notes down here on the second one. This object had a high angle trajectory. As you can see right here, that's a high angle trajectory. Upon impact with a vertical angle of approximately 67 degrees measured from the plane of the windshield. All right? 67 degrees, definitely high angle. All right, now, when you start getting closer to 35 degrees is kind of like the balancing margin between the lowest elevation of a high angle and the highest elevation of a low angle. And as I've said so many times before in my videos, high angle comes down and then the blast goes backward. Low angle comes in and logically the blast goes forward because it's kind of like skipping off, right? But it hits too hard and doesn't really skip and just kind of like furrows or digs a burrow even, you know, or goes in a hole. All right. Now, as you can see right here, I did the screenshots to show the scientists and NASA that it was 67 degrees. Now we're coming down here. Woo, I had to take quite a few photographs of this bugger right here before I actually, oh, that's not the sun after all. It just dawned on me. That's the frickin' flash on my frickin', doggone it. If I'd have known that, I'd have turned the flash off. But this was a really perfect picture, other than the stupid flash getting, you know, reflecting out of the glass. And I love this thing. It's this, here's your oval. And what's really interesting is the object came from this direction and came from this back azimuth. And right there, that little tiny circle, that is the point of impact. Or also could be what you might refer to when you're looking at the Earth, the point of penetration. However, this object did not penetrate my windshield. Thank God. I really would have freaked if it did that. It'd be like, you know, you're driving down the freeway and suddenly you pick up a hitchhiker, and that hitchhiker happens to be one of those chain-linked frickin' wasps. Yeah, gets a little scary, right? All right, now, yeah, now they give that's my perfect picture right there. And right here, then the red circle outlines the pop. Bloop, bloop. Then we go down to the next slide. This is where I really start giving it to NASA. I'm like, oh, check this out. I have all kinds of verbiage to tell you about here. All right, so there it is. I had to squeeze it down a little bit here because I wanted my picture to be bigger. The red line in this photograph outlines what I would have identified to be the blast bow wave, or the B2W as I like to call it. We know this object was inert and not explosive. That's kind of like an oxymoron, inert, not explosive, but some folks might not follow my meaning if I don't kind of like, you know, double it up. So then, why did its impact leave a bow wave? So we're looking at this here. We have our little pop right here, and we have the consistent bow wave from the impactor here. Yet there was no explosion to create a bow wave of landmass built up like a small half-moon ridge. Okay, that's generally what you see is a small half-moon ridge at these impact sites, and this is not a ridge. So it really makes me take a step back and think about this. Okay, so it still created a bow wave. Interesting, very interesting. All right. Yeah, I'm going to find my other sentence. This is evident of an inertial impact bow wave. Now I made a whole new category of bow wave here. The I2BW versus the B2W. All right. This now sheds light on the three largest impactors to ever strike the surface of the Earth early in its planetary developmental evolution. This planetary developmental evolution would have been when the Earth was not completely solidified and the planetary suture most likely had not sealed. I want to do that down there. All right. Oh, whoops, I went too far. The mid-Atlantic ridge is Earth's planetary suture, forming the yin and yang shape found between the continents on the Atlantic Ocean, North America, South America, and Africa, and Europe. That's where your S shape is coming from. It's not coming from plate tectonics. It's coming from, oh well, we'll get into that part. The continental shapes are a matter of continental precipitation rather than formed by plate tectonics. So, as the primary vortices are churning when the Earth was semi-molten on its surface, right? And the suture, the mid-Atlantic suture, had not sealed, had not come together to where it is today. You basically had a lot of material from the continental mass of Pangaea, which would have originated in the North Pole at the time the Earth was rotating, and very, fluid, maybe not superfluous, but fluid, and had a higher viscosity. And so the continent, by centrifugal force, begins to come down and rain down like Virga from clouds. And then as it's raining down, the vortices, the primary vortices, take it into a spin and curl it. Okay, and this is how you end up with the yin and yang curling of the suture. This also explains why the suture is vertical and not horizontal. I would have expected the suture, the planetary suture, to be horizontal at first, and I tried to imagine, already suspecting that the mid-Atlantic ridge was the suture, imagine that as the equator, especially since scientists have suggested that the Svalbard Islands, with one of the planet's oldest fossilized forests, indicated that it might have been an equator at some point in time, or they were at the equator. Well, see, so as it turns out, that's not the case. However, my theory is, in support of the Svalbard forest, is that it indeed thrived on the nutrients provided by the mid-Atlantic suture when it was really spewing up some good stuff, kind of like all those rock trees and things to give life, in a spurt of time down around the volcanic activity in the trenches of these ridges, right? So, anyway, I'll go back down here. The continental shapes are a matter, and we already talked about that, matter of continental precipitation. And it's called continental precipitation. Why? Because they precipitate. I mean, it's like rain clouds. It's precipitating. We can see how continental precipitation occurs by analyzing the coronal holes, the very, very large coronal holes, which I've sent analyses of to NASA. Precipitation formed by the sun's north and 4 equatorial primary vortices. So when you're looking at the sun, basically the north pole of the sun has a colder region than the south pole because it appears to be larger. The colder, dark spots being larger, to me, says it's colder, which means I believe there is a bow wave chill factor that cools it off on the North Pole more so than anywhere else, and galactic gravity striking the base of the solar system is what pulls the matter down as it is centrifugally brought down toward the South Pole. Boomy-fur is floating in the air. I don't know if you can see it, but it's in my face like a bug. Okay, now, imagine all the other boomy-fur in this room. All right, so we got all that down. Monkey fur, too. All right. Yeah, they're long-haired. They're Pomeranians, so they got frickin' fur for everybody. All right, okay, so it's raining down, right? And as it strikes it gets pulled into it's basically spun around in the retrograde direction on the North Pole, comes down, gets pulled into the vortices at the equator, and then gets curled. There's your continents. There's Africa. There's South America. Makes sense. All right. Now, that might have... Whoops. I went too far. Now back to my bow wave stuff. All right. Now we're ready for the next one. Now, the yellow circle here, as I show it down here, I'll go ahead and read it to you. In this photograph, the yellow circle outlines what I would have referred to as blast ring number 1, BR number 1. We now know this will be identified as fracture ring number 1 because it didn't have a blast. It didn't explode in my face. Thank God it didn't explode in my face. Not that I haven't had things explode in my face before. So it's fracture ring number 1. Notice how the POP is not necessarily, point of penetration, is not necessarily top dead center, TDC, of FR number 1. The fracture on the right of this photograph would have occurred first, followed by the shock traveling toward the left side of the photograph. So, because of the direction that it was traveling and my car going forward this way, okay, as we're looking at the photograph, the object came from this direction and smacked the glass, smacked it right here, and it was large enough that it kind of like caused these guys to shock out like this. After it struck the first fracture ring right here, then your subsequent fracture rings through energy transferred toward the bottom of the windshield and then toward the top and so forth. And you'll notice that there are no fractures on this side because it struck the windshield as I'm going toward you like this. It struck the windshield, bam, so all that energy hit like this and pushed like that. Now, here's what I associated that particular behavior with. Normally, with asteroid impact sites on the Earth's surface, we will see the I2BW is much closer to the farthest edge of FR number 1. Farthest edge, this is the farthest edge. How is it farthest? It's farthest from the direction of flight. Okay, so that's where it goes. All right. For example, farthest edge measured from the POO, or the point of origin. We will also see fracture rings that are more circular by definition than this oval fractured shape. The South China Sea impactor, SCSI, presents us with a high angle trajectory barely above low angle and an elongated oval shape. The SCSI is the only one of 4 largest impactors recorded on the Earth's surface that opened a gaping hole, maybe. I'm still trying to work on that one. That hole turning what is now Indonesia into its own vortex. All right. I theorized the SCSI, South China Sea impactor, was the most explosive, possibly being comprised mostly of ice. Now, when you take something like ice and you throw it into a hot pot of lava, what does it do? Boop! Blows up, right? You got a hot pan sitting there on your stove and you pour water on it. What does it do? Ping, 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 all over the place, and hopefully it doesn't ping into your face or your eyeball. All right, now, I theorized the SCSI was the most explosive, possibly being comprised mostly of ice. That is a 46.9, approximately 46.9 kilometer diameter comet upon impact. The other 3 asteroid impacts were what I categorized as world-class impactors and are the Guacanayabo impactor, the North Pacific Ocean impactor, and the Antarctic impactor. I never did any analysis of the Antarctic impactor. Why? Because Antarctica is frozen, and the only ones that have any evidence of the impactor is NASA, who discovered the impact crater, using gravity, instruments that measured gravity, right? Well, the impactor strikes just like the South China Sea impactor. It strikes, it creates a vortex. That vortex in and of itself generates its own gravitational field. All right? And so you have a stronger area of gravity in that particular point. And then they realized there was a freaking hole there. Dirt. Okay, so... Alright, now, was that it for these guys? Oh, we got more stuff down here. Yeah, this was my thought afterward, right? It's a good thing my car didn't have a planetary rotation to compound the resulting damage from an impact. This is when I thought the car would be rotating like this and forgot it would actually be rotating like that. So, or didn't imagine it being like that, so I was wrong. It would have been less. It would have just been, boing, been fed off into the wild, or it would have redirected it into somebody else's windshield. All right. My car, if it was Earth, would have been rotating toward the right side of this photograph. Now we know that's wrong. The forward velocity coupled with the rotational velocity of 9 Jupiterian stripes would have caused a great deal more damage. Again, my rotational direction was incorrect. However, the 9 Jupiterian stripes is not incorrect. That's on the money. It also might have caused the POP and I2BW to be closer to the farthest edge of FR number 1, respectively. Whatever the object was, it was a singular, solid piece of matter that did not leave residue, break, or disintegrate upon impact. It merely struck and ricocheted. Somewhere around here, I put some stuff down there I was talking about. All right, there. Sorry, there's silence. Sitting here trying to figure out I missed something. There's something I didn't talk about. Matter of precipitation. I talked about precipitory continents. Thought I had more in here about something. Now I can't even remember what that more in here about something was supposed to be. All right. I thought I talked more about... I did. I talked... At least at one point I wrote down more about the 9 Jupiterian stripes. I went into greater detail. Oh, you know what? That was the email itself. I also sent the email itself. Oh, well, shoot, I could go ahead and pull that up and share that with you. Where it be's at. It's coming. Derp. Waiting on Googa Deagle. Go to Gmail. All right. Where it be's at. Let me see. Okay. Derp. Let me see. Yeah, it must be this one. VW Part 2. Was it VW Part 2? No, it wasn't VW Part 2. I didn't do anything with that one. Okay, back to the list. Okay, so it was... I gotta go to Sent. There it was. Planet VW Part 2. Nope, it was Planet VW. There it goes. What the heck? Where's the words? Oh, that was to me. Whoops. Sorry about that, guys. That wasn't to NASA and those guys. Okay, where's the one that says frickin' Planet VW going to... what was that? Well, I can't believe I can't remember none of this stuff. Okay, forces behind the universe. Nope, that ain't it. The size of an impactor. Alright. Why is Planet VW behind this guy? That's strange. I watched... Oh! Did it. To Dr. Simmons. Alright. I sent it to Dr. Simmons, NASA, and Dr. my bad. Dr. Kreider. I like Dr. Kreider. She's really nice. Hasn't answered any of my emails. I've only emailed her like once. So for all I know, her email network marked me as, being a risk, and so naturally not knowing who I am, or not remembering who I am, we did meet. Okay, anyway. Okay, a large orange-brown object flew across and over a median Jersey barrier on a freeway in Washington State and struck the window of my Volkswagen. Rock versus asteroid. The similarity is that of an asteroid impacting the Earth. I am a retired field artillerist and an expert in crater analysis. Alright, inertial impactors. The object that was flung into my windshield ricocheted at a near perpendicular angle, or so I thought. So much so, other vehicle operators behind me backed off. That was true. I watched them. They were just like, there was a truck driver right behind me. He saw that thing coming, he saw it smack my car and go doink, and he braked. He slowed down a lot. He's probably worried that I was going to start swerving and stomping on brakes and crash. I don't know. I have no idea what the object was, but suspect it was catapulted by a tire in the opposite traffic or something that fell out of the back of a vehicle with a poorly secured load, which happens. It left a fractured crater in my windshield akin to an inertial impactor. I am calling this an inertial impactor, for lack of a better term, to describe an impactor that possesses no unstable or explosive properties. For example, rock. It was probably a rock, but I don't know, just a very ugly rock too. It wasn't dolomite or anything like that. It was or dye or anything like that. Yeah. But anyway, can't think of any other rocks. All right, crater analysis. The crater formed by the object pricked a central impact point, forming the shape of an oval fracture around it. The oval shape is better outlined on the passenger side of the fracture, indicating the windshield absorbed the shock of impact by flexing inward more so on one side than the other. This basically means like a professional boxer being struck in the face by his opponent and his cheek on the opposite side of his face flexing outward, bam, woo! You saw those photographs, I'm sure. There's like one really popular photograph of that poor guy that his face was, if it was like Looney Tunes, his face would have left his skull. That's how bad it was, right? All right. And, right, on the face of the outward. My windshield behaved in a similar manner. Sorry, my tongue got tangled and it sounded a little strange. Determined in back azimuth. The oval inertial impact fracture also reveals the object's point of origin. Poo. That's right, poo. The poo. Where did the poo come from? The poo came from over there. How do you know? Because I watched and I made a little line. I drew a line back to the poo. Found out who pooed. A back azimuth will determine the direction of its approach. The spider leg fractures radiating out from the point of impact, the POI, similar to a point of penetration, or POP, are unique to the shape, velocity, and vertical angle of this object's flight path. The crustal behavior. Imagine the windshield of my car is the crustal layer of Earth's surface. The vertical angle, VA, of my car's windshield represents the region of the Earth's surface where this theoretical impactor would have struck. Galactic flight posture. The Earth's galactic flight posture, GFP, orients the North Pole at approximately 25 degrees above the galactic plane. This is the part I wanted to tell you about that I thought was in the slide, but wasn't? Yeah. All right. The galactic and solar system rates of rotation appear to have a general effect on the angular momentum of celestial subjects, suggesting the universe possesses an average rate of rotation. This average rate of rotation is further identified by the presence of 9 Jupiterian stripes. For example, 9 Jupiterian stripes coupled with 9 northern rings and 9 southern rings for a total of 27 stripes and rings. The number of rings represents the speed of rotation. So the angular momentum of an approximate range around 25, 27 degrees, so on and so forth, is typically relative to an overall average that appears in different settings, okay? And the 9 Jupiterian stripes that we see, primarily around the equator of Jupiter are also shared on the surface of the Earth. That's right. I mapped them. I mapped, basically, pretty much mapped 3 sets for sure and had 1/4 that was theoretical. So, that tells you the speed of rotation. So right now, 9 Jupiterian stripes indicates for a ball the size of Earth, it creates a rotational rate of 24 hours in 1 revolution. Got it? Got it. And now apply that same principle and you determine the rate of rotation for 1 revolution of a planet the size of Jupiter, so on and so forth. Okay. The faster the revolutions per second in a centrifuge, the tighter the cinnamon rolls. That's how it works. Rates of rotation. The attached PPT illustrates my initial evaluation and analysis of this impactor's fractured oval crater. There are 3 photographs of my windshield providing a view of the inertial impact fracture from 3 separate perspectives. I parked my car close to a service road bordered by a Jersey barrier, much like the one on the highway I traveled at the time of the impact, right? Excuse me. Hopefully this will recreate a close relationship to the original position. Yep. All right. Well, that's it, folks. I mean, that's my stuff right there. Oh, yeah, here we go. So you go down here, you see my doggone, there's my planet VW. And then we have my, GFP right there, and we got the smack, and the smack. This is short smack, long smack. All right. That's all I have to, I would say, be sure to like and subscribe. Don't bother, because I don't care. I'll just continue to put the stuff out there as I come along. Thoughts that I would like to share with whoever is willing to listen. And thank you for watching if you actually bothered. Alright, that ends my presentation. I'm going to go ahead and click out of this thing now.